And today I'm gonna talk about EBFE trick, which is for attaching the target process, which the code is injected on it in the OlyDbg. As we said, it's not always possible to attach it in OlyDbg. We want to show you EBFE trick that lets you to attach to OlyDbg. Here I already opened sample 18.1. I'm gonna restart it again and as I showed you here, I have the breakpoint in open process, allocate a virtual memory, write process, virtual memory, and after that create remote thread, which is for for running the code in a target process. Let's go to the first breakpoint. I'm gonna run the code till this breakpoint. We are in open process. When we are here, it said that the process ID is AB8. Let me check it to see hex to decimal. Here. The number is AB8. AB8 after converting is 2744. Let's open the process hacker. 27 AB8 2744 27 25 2744, which is this notepad. Let's go over open process. We're gonna step over it, or I can run till allocate a memory. Let's run here. In the allocation of the memory, is gonna allocate a virtual memory on the target process. Let's step over it to have the allocated memory. Let's step over and then continue till reaching write memory. Debug run. I'm in the right memory. It's gonna write a memory in the address A1000 in a target process, and the buffer is starting from 7C FA17. Let's go FC. Let me go to 7C FA. This is the buffer, and the first two byte is FC33. Remember this number because we're gonna change it and this buffer, and after that we're gonna come back to change it to the original one. This is the buffer would be written in the containing malicious code will be written in the target process FC33. Let's go over it till running create remote thread. From now on, you know that what we did is opening a new instance of OlyDbg and file. We need to attach that notepad. But what we do, suppose that we are not able to attach it, this notepad ABA to the OlyDbg. What we have to do in an open process, go to this 2744 and double click on it to open the memory. I think the reason it doesn't open because I might run the process hacker in administrator. Mode process hacker, run as administrator, yes. And let's go to file 2744. I'm gonna open it. Now we can see the memory. It's written in I didn't take a note of this one. Let me double check what was the address. It's supposed to be one of these read or write exe which are private. Let me get back to the code and resume the video. While writing the memory, virtual allocating memory, we had the address was A1 something. Based on that, we know that this is the address for the memory block that is written, and it's read or write exit. I am gonna double click on it, and here you see that it starts with FC33, which is the first command in instruction in the which is injected. I'm gonna change it to the characters we have is I'm gonna change it to EB. Let's see if I can change it. E. Okay, we're gonna write EB F EB F E, and after that write and close. Let me double check it. EBFE, close. And after that, if I click here attach and find my notepad was AB8 and click the attach, is gonna be attached here. Let's go to the address we had in the code. Let's see what was that. It's written on the first character in the injected code. The address was 1A. Okay, to find the address in the attached one, I put Control G, because in the previous debugger, you see that the EAX is A1000, and we in the process hacker we we see that. Let me open the process hacker. For let's see 27, this one, we see that A10000 is the address of the place we change it to EBFE. What we after putting Control G in the after attaching to go to this address, I put the address of the Control G and write the address of the place that the code is injected. Click enter. It's gonna go to this place. What we see here, EBFE is the instruction change to jump short the address. This address is similar to this one. Jump instruction is like this. You say, for example, jump 2, it means 2 instruction and 2 address ahead. If whatever this address is, if you put 2, it's gonna go to 00A10002. If you put jump -2, it's gonna go to 2 address before. And is a relative address. It means that from the place it is, jump how many, for example, 3 to any number of the addresses you want to go ahead or before. But when you put FE means itself, and it means that jump to itself. And what will happen when you put EBFE? It means that the code will continue running to itself, and it's not like it execute the rest of the instruction and you won't have to attach it because it's already running. What will happen when it's looping in itself? You have a chance to attach to OlyDbg and step over this instruction to go by for rest of them. Since it's here, if you run it, step over is gonna step to itself. What we need to do, we need to change this address. Sorry. No. I'm looking to change this code to FC33 as it was, but seems that I couldn't change that here. What I am doing, I'm gonna put no operation to see. You see, it put 2 no operation instead of 2 here because it was 2 byte over there. And after that, if I'm gonna go through these ones to check the bytes, I'm gonna search a bit to find out if I can change it to FC33. But anyway, we can change it to no operation and continue debugging. Okay, I got the point. What we can do, right click and find the binary and put the edit. Instead of 90, I can put FC. Okay, and here it can be binary edit 33. It's gonna be edit again, edit binary FC33, FC33. It seems that it's continued with the rest of the block, and that's what we need to what it was before. It was clear. I think this now is but instead of doing no operation in the first place, I have to do that one. Let me file attach. I already changed it, but let me attach again. This one, attach. Okay. Terminate. Yes. File open. I think that it's already saved it, but anyway, let's try one more time to see that it was notepad. It's already closed. Sorry, it's closed right now. So anyway, instead of doing the assembly, you can do change the binary. In that way, you can return back to FC33.